In this series, I shall be teaching you on how to load images onto this astrometrical interface here, and also I'll be taking you through the rules of searching for asteroids, like to have a successful campaign in the asteroid search. So this is the interface, the astrometrical interface here. So I would like to load some images here. But before I do that, I would like to take you through the programs that through some data we have downloaded before. So go to my folder. Then remember that we've extracted this before in our last video. Then you click on practice image sets. Then you see the 5 images that are inside these practice image sets. So there are 5 of them. We're going to be analyzing the 5 of them, but maybe I'll be analyzing any 3 while you use the rest to practice more. So let me just start from the first, and I'll extract it. Extract file. Okay. So the file has extracted. Let me explore what's inside. So inside we have 4 files, and these are fit files, the 4 of them. So each one represents a particular time the image was taken. They are taken at different times for equal time intervals in the sky, and this is the date the image was taken. So if you observe, this is 2019, so it's a long time ago. So it's no longer valid, but we can use it for practice sake. So let's load it onto our astrometrical. But before we do that, I'd like to show you something. I'd like you to observe that this is a PS1 image. So this will determine the kind of configuration file you will have to activate before you analyze this. You have to activate this configuration file. In some modern data, you have PS2. So you have to take note of that. So let's go back to our astrometrical, and we check our configuration file, and we have this says PS1. So I can go on to load my images right away. But assuming that you are having a different configuration file, you go to your settings, you go to open, and you will see those configuration files. Then you choose the one that applies to the data you want to analyze. So for the Isaac campaign, we mostly use PS1 and PS2. And like I've said before, the modern data that you'll be receiving from Isaac are PS2. So I expect you to configure to PS2. But for the sake of what we're about to do right now, we have PS1, and I have already configured to PS1. So I'll just go ahead and click on open. Then okay. So I have PS1. So the next thing is to load my images. So I click here. Then it brings me this window. I will go ahead to locate where I stored the data in my system, and in my system it is my downloads. So I just click on my downloads. This is the practice image sets, so I click on it. I have my practice image sets. I would like to see the whole folder so that I know where I am. So this is all the data that I have downloaded before. Then I'll go ahead and click on that first one because I have extracted it. So you click on it and click again, then you have the four images that we saw before. So next, you highlight all of them at the same time. Then you click on open and allow it to load. So the next thing to do is to change the background. The background at present is dark while the objects are white, but we need to invert it. We want to have a white background here. So you click on invert images. I have demonstrated it before. I've shown you this before in the last video. So click on invert images and it changes to white. If you want to bring it back, want to bring back the dark background, you click on it. If you want to bring back the white background, you click it. You see that? So the stars, the reference stars and the object in the background are dark while the background is white. Next, we'll check on isometric data reduction. If you remember, this was inactive before, but now it is active. This is because we have loaded our images. So click on it, and a small window pops out, showing you the coordinates of the patch of the sky this image was taken. This is the right ascension, and this is the declination. And this is talking about, this is showing the whether it is from the southern or from the northern hemisphere. And you can click on this spot to see the objects that were in the sky during the moment this was taken. So you can scroll to see all of them, about 10,000 of them. Anyway, you can just click cancel after seeing it and you click OK. Don't make any changes and allow it to load. So how fast it loads depends on the speed of your internet. We have an error sign says reference star match error. It's a common error though, so it simply shows that the astrometrical program cannot match the reference stars by itself, but you can do the matching by clicking on automatic. Then you click OK without making any other changes. At this point, some of our participants, when they click OK, this window here, this small window here, keep coming out, keep popping out. So they keep clicking OK, OK, OK. So if you are having such difficulties, if you're having such errors, I would suggest you uninstall and reinstall the asymmetrical program. And when you come to this stage, you won't have such issues again. So I'm not having the issue, so if I just click OK, it will just complete the loading. So after loading, you will see green dots everywhere here. Green dot, these are reference stars and reference objects. And you have a small table here showing the details of each of those four fit files that we saw before. You can see the reference stars. This was 8280, and you can see the coordinates of these files, those fit files. But we don't need it, so just click on close so that it doesn't obstruct what you're going to be doing. So I'll click close. Next, after the data reduction, you click on known object overlay. This will help you to to differentiate between the objects that have been discovered by other citizen scientists from the ones that have not been discovered by anyone. This is important because if you do not do that, you will fall into the error of claiming someone else's discovery as yours. And if you report such to Isaac, you will not be accorded such discovery. You can't claim it is yours. So it is important that you click on the known object overlay and you will observe what is going to happen after the load. All right, good. So these are the these are the known images. And if you observe again, this is 25%. Each of them contribute 25% to the whole thing. So if you want to see it, you see that. So they are the same. If I stack them together and animate them, it will give me a sense of motion. So after this, you should click on blink images. Blink images. So this is the blink tool, blink current images. So a fifth window will pop out. This is the first, second, third, fourth, and this is the fifth, which is the window showing the animation. And if you observe, this is the first, second, third, fourth, so on. So it is simulating the four images here, producing producing a sense of motion here. So you can zoom in 2 times or once. I think once is okay. But before we start searching for asteroids, we need to understand the rules on how to have a successful campaign, on how to discover asteroids, what you're supposed to be looking at, and what you're supposed to ignore. So let me take you to the manual that we downloaded before. And this is the quick start guide. And like in the past video, I told you to read through these two files here. So then, but in this case, in the case of this video, we're going to be seeing this file, revised signature guide. And let us learn some stuff there. So this is true and false signal. True and false signal. So what is a true signal and what is a false signal? So you can take your time to read this. Do you understand? But I want to just point out. I want to highlight um the important points. For our signal to be true, it must obey these three rules. First of all, it must be moving in a straight line. So it can be moving in the maybe in the three images it will appear to be moving in a straight line, and then the fourth one it will appear to be bent. No. Then it must move at a constant speed, and it must have a fairly constant magnitude. So this is the rules for being a true signal. That if you scroll down, you see some other things, example of moving objects, and I would like to see example of false signals. This is very important. Example of false signals. So look at this object. It was spotted. So during your campaign, you might see some stuff like this. So, but if you want to accept this object, you have to verify some of its properties, which include this Gaussian curve and this line. So, if you observe these white dots, they are scattered around the red line. In both cases, they are scattered around it. So this is a false signal because of this. It is a false signal. It is scattered around the red line. But assuming they are clouded around the red line, it becomes a true signal. So for true signals, the white dots are usually clustered around the red lines, here and here. So from here it says this object would be rejected because although they appear to move in a linear direction, their shape and the graph indicate they are artifacts. So these are objects that are masquerading themselves as asteroids. So you can go on and on to read further. So you see it is scattered around it. Scattered around it. So it's a false signal. Artifact must, must not be included in NPC report. So you don't include artifacts. So all artifacts are not moving objects, are not asteroids, sorry. So false signal. Another rule is the magnitude. This object is also rejected because the magnitude fluctuates by more than 1. Okay, this is the R value, this is the magnitude, this is about 21 or so. This is the absolute magnitude scale. Then this is also the magnitude, this is the magnitude 20.4. This is 19.1. We have a way of calculating this absolute magnitude, which I will demonstrate to you in our next video. But let's go ahead to see all the rules. Also observe something here. I want you to observe this S and R. This is the to signal to noise ratio. Signal to noise ratio. Part of the rule says that it must be greater than 5. So if you have a signal to noise ratio that is less than 5, is also a false signal. I think you can read that if you peruse through this manual guide carefully. And if you go ahead, it also says that you shouldn't include bright objects like the stars. You shouldn't. We're not looking for stars. We're looking for asteroids. So this is a saturation from a bright star. Never measure and report saturated object. So there are many rules here you can take note of while searching the asteroids. Then we have this one. It says known objects do not need to be included in MPC reports. This is very important. You do not include known objects. Those ones that have been labeled. This is this has been discovered by other citizen scientists. So you shouldn't include them in your MPC report. So you go straight and look for the ones that have not been discovered. Then we have the manual search. So I would advise you to go through this manual carefully so that you can learn some of these things. But you can also follow me step by step because I'm going to demonstrate every single thing that was stated in this manual during the campaign. Sorry, during the search. So let me go back to the program. So this is it. So I would like to do this. I would like to start the search properly in the next video. Thanks for listening.